Let's talk about math. We know it's important. In fact, a preschooler's knowledge of math can predict his success all the way through high school. And any country's success in the 21st century will clearly depend critically on the math and STEM skills of its people. Yet somehow we're failing at it. When tested in 4th grade, only about 1 in 3 US students shows proficiency in math, despite enormous focus and investment. No matter how much we spend or how hard we try, kids are still struggling with math. So what can we do about it? Well, if math is so important and our future is literally riding on it, shouldn't we be willing to take another moonshot to figure it out? But wait a second. What if someone already figured out what to do? In fact, around 1990, a few cognitive scientists wanted to know why some kids show up in kindergarten and start to succeed at math, and some show up and start to fail right from day one. They identified a core set of skills they called the mental number line. Any kid that understood these skills would have number sense and would succeed at math. Any kid that didn't was almost guaranteed to struggle. Sounds good on paper, but how about in the real world? Over the next several years, researchers took the mental number line and executed a series of landmark research studies to see if it could be taught, and if so, what impact would it have? They followed several groups of kindergarten children. In one control group were kids from middle-income and high-income homes, those who traditionally would start tracking towards math success. In the experimental group were kids who were more disadvantaged and would typically be at risk for tracking towards math failure. Now, all of the children attended their school's traditional math instruction, but the intervention group was also given 15 hours of hothouse instruction on the mental number line through a curriculum called Right Start over the course of a few months. The researchers hoped this intervention could reduce the gap between the children who typically succeeded in math and those who didn't, and in fact it did. By the end of the year, the Right Start group had significantly closed the gap with the top performing kids in the class. But even more startling, the researchers continued to test the two groups of kids over the next 3 years, and found the Right Start kids not only kept pace with the control group, they ultimately outstripped them, showing a much better grasp of math concepts than the group that would normally outpace them. When they set out on this study, the researchers thought they might be able to reduce the gap, but even they were surprised with the magnitude of the change they found. Now, the initial results were extraordinary, but to ensure it wasn't just a fluke, similar studies were repeated multiple times over a period of years with consistent results. Which raises the question, why wasn't this solved once and for all in 1994? Right Start showed that we could take literally any kid from virtually any background and teach them number sense. But teaching every kid is a much harder problem than teaching any kid. To get to these results at scale, we would need to somehow deliver individualized instruction for every child at whatever level they were at. But how could we accomplish that? We could assign a teacher for every kid to adapt the instruction as they learn and stay with them moment to moment, but this approach would be way too expensive. We could use the internet to deliver access to every child, but the internet by itself can't individualize. We'd need an interface that wouldn't get in the way of the learning. For young kids, paper certainly wasn't it, and the desktop computer with its mouse and keyboard just didn't go far enough. So we almost had the answer, but it just wasn't meant to be. In the 1990s, we could teach any kid number sense, but we just couldn't roll this out to every kid. But wait a second. Almost 20 years later, in 2010, clunky desktop computers had finally given way to intuitive touchscreen tablets, and young kids everywhere had quickly taken to the new devices as their own computer revolution. A year later, in 2011, we started Native Brain with a very simple question. Can we finally bring number sense to every child? Well, let's review. By 1990, we knew what to teach. By 1994, we knew how to teach it to any child. And by 2010, we had intuitive interfaces we could use to individualize to each student, and we also had advanced dashboard technologies for tracking. In fact, by 2011, we had all of the raw tablet, computing, and web technology we need to individualize instruction for each child and support teachers in real time. So what would the solution look like? Well, it would start with the same mental number line blueprint used by the researchers in the original 1990s study, but this time it would be delivered to each student on a tablet device. This is what we call native numbers, and so far thousands of kids have used it to complete millions of tasks on their journey towards number sense. Teachers and critics with solid learning credentials have begun to recognize and comment on the depth of the app's potential as a game changer in early learning. And kids everywhere are being introduced to math as an intrinsically engaging subject. What do we need to do next? Thousands of kids have already experienced native numbers and number sense, but millions of kids have not. We need your help. If you know a parent who has a young child who's learning math, tell them about the app. If you know a teacher who works with young children to help them learn math, tell them about it too. In short, spread the word. If you're as excited as we are about the idea of every kid learning math, and more importantly, learning to love math, share this video with everyone you know and help us get every kid to number sense.